Welcome to the first session, session 1 on design project and project management. A project is a complex task and needs to be properly managed if it is going to be successful. In the last session, we tried to look at some of the reasons why projects fail. So in this session, we're going to try to understand what projects are and what project management is all about. In the course, we will take a look at the concept of projects and why it is important to manage them for a successful completion. We will also talk about project lifecycle and its relation to project management and systems development. This introductory session will focus on the very basics, at the end of which you should be able to understand a number of things. You would have a rich experience of what you meet in industry, as well as a sound foundation for your final year project. We will work through the phases of a technical project, but in this first session, we'll talk about the characteristics of a project, the main project management activities we need to be aware of, those criteria that define a successful project, and we will also look at project life cycles. So, what are the learning outcomes? We want you to be able to describe the characteristics of a project, outline those activities that constitute project management, understand the criteria for successful project, describe in overview the project life cycles, and explain the different system development life cycle approaches and models. So, what is a project? That's a key question. And what is project management? What activities are involved in project management? Upon what criteria should we judge if a project is successful or not? And what is project life cycle? What is involved in the project management life cycle? What different approaches are there to systems development? Most of you, I'm sure, you've come across the word project. But what is your understanding? What is your definition? If you take any dictionary, a common definition you find will be, for a project, will be a specific plan or design, a plan undertaking, a large undertaking, e.g. public works schema. But the Project Management Institute, in their PMBOK book guide, defines it as what? A temporary endeavor undertaken to create a unique product, service, or result. It must have a definable purpose from this definition, that it's got a definable purpose. It's a unique undertaking, and it's also temporary in nature. There are a number of characteristics that distinguish a project from the definitions that has been given. So you realize that there are no routine tasks that are involved. They need some planning, to have some specific objectives. It will have a predetermined time span. Normally, you would carry out the work for someone other than yourself. The work may involve the use of several specialists. You may have some temporary work groups that are formed to carry out the task. The work may be carried out in several phases. And importantly, resources available are constrained. So you don't have the whole resources or the whole world available to you to undertake the project. And of course, it can be large and complex. But why undertake a project? What is at stake for the organization or business? Is it financial? Or can it be expressed in some other terms? Business survival, competitive advantage, entry into a new market, innovation? How challenging are the performance requirements of the project? Is the technology already known, or is it new? Can it be organizational change? What degree of change would be involved? How would it impact on the way the organization operates? what resource utilization things are involved. There'll be time scales, financial cost, resource availability. Now, let's look at this. What would you consider to be a project? In small groups, I would want you to discuss this, each of these, and decide whether or not which of them would constitute a project. So producing, for example, an edition of a newspaper, putting a robot vehicle on Mars to search for signs of life, getting married, building the Channel Tunnel, a research into what makes a good human-computer interface, writing an operating system for a new computer, installing a new version of a word processing package in an organization, a second-year programming assignment for a computing students, an investigation into why a user has a problem with a computer. Some of these might appear more of a project than others. Your task is to rank them in order of what you consider to be more of a project than others. So in small teams, work on this. Teams of 2 and 3. But note that there's no one correct answer to this. Now, what is it that distinguishes software from other projects? You realize that in many instances, software is an invisible thing. So, for example, if an architect or a civil engineer was designing a bridge, you can easily see. So you can compare a physical bridge, with a piece of software. So in software, progress that you make is not visible, but whilst in a physical bridge, you can see the progress. Also, there's something else, complexity. Software projects, its thoughts are agreed, are more complex than other engineered artifacts. Also, conformity. Physical projects are governed by physical laws. You have cement and steel, requirements of human clients, etc. But then, what about flexibility? If you compare software projects from other projects to other projects, what about flexibility? You realize that software projects or software is much easier to change. If you are building a bridge, once you've poured the concrete, you can't change it. So software will change in order to accommodate the environment. And this is a key strength of software projects, that it's easy to change them. It's easy to change the interfaces, etc. So we have looked at what projects are. We've tried to look at examples of what things would constitute a project. But then, what is project management? The Project Management Institute, in their guide, defines it as the application of knowledge, skills, tools, and techniques to project activities to meet the project requirements. The Association of Project Managers also defines project management as a process by which projects are defined, planned, monitored, controlled, and delivered such that the agreed benefits are realized. Now, question that you should think about is, what is common in this? What are the key items here in these two definitions? Are they the same? What is different? Think about it. Ask yourselves. For every project, you need a project manager who plans and guides a software project. This manager plays a crucial role in every project management process. He or she will be responsible for identifying the users and stakeholders and determining their needs. The project manager would coordinate the teams, ensuring that each task has an appropriate software engineer assigned and that each engineer would have sufficient knowledge to perform it. To do this well, the project manager must also be familiar with every aspect of what? Software engineering. There are a number of process groups that are involved in project management. So a number of processes are undertaken to bring any new project to life. This includes the initiating process, which is the feasibility study. And the feasibility study is an investigation to determine whether it is worth starting the project in the first place. For large projects, even this feasibility study could in itself be regarded as a project on its own. Items that are covered in a feasibility study would include, for example, operational costs and the value of the new system. The planning phase would only begin when there is a satisfactory report from the feasibility study. So the feasibility study indicates that yes, there could be benefits, it's worth pursuing this. So then the planning can start. And once you've planned the project, we can move on to the execution stage. And this is actually execution that will begin with implementation of the project. And then, of course, once you are implementing it, there will be the need to monitor and control the processes, and then the closing process. How do you actually bring a project to a close? There are a number of knowledge areas that you must, have or be conversant with in every project management. This includes integration management. What does that mean? Scope management. What does that mean? Time management, cost management, quality management, human resource management, communications management, risk management, procurement management. So for every project, these are knowledge areas that you must have if you are going to manage that project successfully. What criteria should we have for the success of a project? So you begin a project, you execute it, you bring it to an end. How do we determine whether the project has been successful? Is it that it's completed within time? Is it that the project is within budget? Is it that the project is performing at the desired levels with acceptable quality? Is it that it offers the least minimum agreed functionality? Is it that you are utilizing the assigned resources effectively and efficiently? Is it that it's been accepted by the client? Is it that it's used by the intended users? Is it that it delivers the promised benefits? Now, if you think about a student project or your final year project, which of these criteria do you think will be applicable to your final year student project? Now, what factors would influence whether a project is successful or had failed? Or what factors influence project failure? We can actually divide these into three categories. Failures that are technical in nature, failures that are human, and process failure. The table here shows you the categorization of these failures. So technical failure could include things like the lure of the leading edge. What does it mean if it's the lure of the leading edge? Poor technical design. What does that mean? A technical solution to a non-technical problem. Dependence on software packages to satisfy requirements. Lack of tools throughout development lifecycle. Technology-led development. These are all examples of technical failures or failures that can be attributed to technicalities. Then, of course, there will be human failure. What are they? And then also process failure. What are these? For any project, different forms of life cycles may be identified. But for our purpose, we'll consider only two. Project management life cycle, which is concerned with managing the project, and also project technical life cycle, which is concerned with modifying the system. In systems engineering, we will talk of systems life cycle. The main life cycles are shown in the diagram. Note that the system will often be software products. Your system will always be often be a software product. Now, the question is, which of the life cycles shown would need to be considered in a student project? And for each of the life cycles, try to make a list of the activities that may be involved. Try to identify at least 4 specific activities relevant to each life cycle. So, for a project management life cycle, we move from concept, definition, implementation, handover, and closeout. What does it mean? What do those things mean? Concept, definition, implementation, handover, and closeout. For systems development life cycle, we will talk about a sequential, increment approaches. There will be sequential, incremental, prototyping, and evolutionary. What do this mean if you have a sequential approach, an incremental approach, an evolutionary approach, or a prototyping approach? There are a number of system development life cycle models. There's a waterfall model, there's an incremental phase delivery model, there's an evolutionary delivery model, spiral model, dynamic systems development model, the rational unified process model, extreme programming model. The waterfall model was introduced by Winston Royce in 1970, right? And the diagram shows you, with the diagram you can see why it is so called. So it looks like a waterfall. So you start with the system's requirements, and then you move toward software requirements. And of course, that process can itself be cyclic. And then once that is complete, you then move to the analysis phase, and that can then go back to the software requirements phase. The analysis phase then goes on to the program design, which can then lead back towards analysis because of review. And then the coding can lead back to program design, and then the testing, which can go back to the coding and so on. Then the incremental model. In the incremental model, you have phases. So phase 1. And then within the phase 1, you can have the waterfall model. Phase 2 also, you can still have in phase 2, that's increment 2, you have another waterfall model. So this project, whole project, is divided into phases. Each one adding an increasing complexity or adding an extra thing that has to be done. So at the end of phase 1, you deliver to customer. At the end of phase 2, you again deliver to customer. At the end of phase 3, you deliver to customer. Now, can you think of any project where you can divide it into phases, incremental phases, where you deliver bits to the customer as and when they are ready? So basically, that's the idea, that in an incremental delivery model, you have a big project. You don't wait and complete the whole project before you deliver, but you divide the project into what? Phases, and deliver them in stages to the customer. Now, of course, there's a crashed increments. So as you can see, you deliver to customer once it's complete, but before you even deliver the first one, you start the second one. As opposed to the previous one, where you start the next one only after the first one had been delivered. But in the crashed increments, you can start the second one while the first one hasn't yet been delivered. So you crashed the increments. In the rational unified process, so you have this again in phases, and at each phase you iterate. So there's an inception phase, you plan, do, study, act, you go through that cycle. Then you have that elaboration phase where again you plan, do, study, cycle. You go through the cycles at each stage. So you go from inception, elaboration, construction, and transition. So you go through all these phases. And at each phase, you have an iterative process of planning, doing, studying, and implementing. So, what have we learned? In this session, we've talked about what a project is, what the characteristics of a project are. We've talked about what project management is. We also mentioned project management process groups, the knowledge areas as well. We also mentioned the project success and failure criteria, and we began to look at project management lifecycle. We'll talk about the systems development lifecycle approaches and the system development lifecycle models. So you will find more information from the reading list that is provided and from the project management book of knowledge study guide that is provided to you. Now, for exercise, I would like you to list the problems you experienced when you carried out a recent assignment in your studies. So you list some of the problems that you experienced. Then rank these problems in order of what magnitude and consider whether some of the problems could have been reduced through better organization or planning or by yourself. The second one, exercise, is as follows. There's a public library, and they are considering a new computer system to help administer book loans. You need to identify who the stakeholders are in this project and what some of the objectives of the project may be. How do you practically measure the success of this project? So these are exercises for you to complete. You would have to do this and submit to your tutor, and then later on you may discuss that in class.